All right, let's do a little test. Testing. 1, 2, 3. Okay, great. I am going to do that every time, just because that one time I got cut off by 15 minutes at the start. Although, to be fair, that was when I tried to schedule the stream, and then YouTube was like, all right, your stream has started. And I was like, great. And then OBS was saying I was streaming, but then it just wasn't. I don't know. Anywho, let's get into what we're going to do today. But before we do that, I'm going to take a sip of my hot peppermint tea. It's no longer scalding. Still very hot though. So, for this stream, we're going to implement, hopefully, finish implementing symbol scopes, so for variables. So for example, this code runs, but it should not work. This code doesn't seem like it makes any sense. We've got an X and a Y, and then we return add with no parameters. But what's happening is the X and the Y are getting stored in the symbol table as if they're global variables. And then add, there's no actual checking for parameters versus arguments. There's no type checking or anything. So we call add, and then it looks up X and Y from the globals and then just returns those. So this does run and work, but it should not work. It should be totally incorrect. There should be an error here saying it's got the wrong parameters count. And also, and also these variables shouldn't be picked up from the global symbol table. So we're going to have to fix that. But first, I want to actually go back to what I was starting to do yesterday. So what we're doing currently with local variables is we're allocating storage in registers if registers are available. Where is it? Here. So we've got reserved register. However, if I look at something like, if we go to the compiler explorer at godbolt.org, very cool piece of technology, and we have a look here. I'll just type in some variables, x equals 40, y equals 2, and you can see on the right, all right, we're actually allocating on the stack in this case. So, oh, that's interesting. Looks like my intuition about moving the base pointer at the start of a procedure was the same as whoever made this. Welcome in, Tiru2. How you doing? Tiru2 says, you're actually making a programming language, ? Yes, that is the thing we're working on at the moment. So as you can see here, it's immediately allocating these on the stack, which I looked into a little bit, and apparently it's better for debugging because then you've got a stable address. It's not in a register that you might need to push and pop at various times. So we're going to do that as well. I'm going to stop reserving registers, and I'm just going to push stuff onto the stack straight away, which is, of course, going to break a lot of the code. So let me just write out a to-do list. I don't think I have a to-do. Oh yeah, that's the wrong command in Vim. All right, so I've got a to-do list. So let's have a look. We're going to stack allocate all locals. Good for debugging. And what else are we going to do? Oh yes, we're going to have to create some kind of data structure to store scoped symbols. So that could just be a stack, I think. But I'm not entirely sure how I'm going to do that yet. And also, bonus, If we get time, we'll try to get the float registers working. Not float registers, but float parameters. Alright. So let me just get rid of this. Alright. Looks like I've got some NeoVim plugin that I don't remember installing, where I could probably press a hotkey to tick these off, but I don't remember what that is. Anyhow, that's our to-do list for the stream. Oh, I can take off my headphones now. There we go. I wear my headphones way too much. Turu asks, wow, that sounds advanced. Is it going to be based off another language or from scratch? Sorry if this was a bad question. No, that's not a bad question. It's a little bit complicated of a question, depending on how deep you want to go. Like if you're just looking at the syntax, then syntactically it's based on Jai and Odin, which I guess themselves are based on older languages, Pascal, C, probably some concepts from Algol 68 since it had everything apparently, and etc. But if you mean, am I extending a language? No, I'm not extending a language. So I'm building the language and then parsing it, converting it into assembly, and then assembling it. So I guess you could say I'm building on assembly because I'm not writing my own assembler right now. So right now we output code like this, and then we use the assembler to make an object, and then we link that with a linker. But in the future, we probably want to add this into the compiler itself and have our own assembly dialect. Now, why did I save that? What did I just do? I don't even know. All right, anyhow. So if we have a look at reserve slot, we don't want to reserve registers anymore. And I remember I did this last night, but last night I was very tired. So we can just return, in fact, we could just return this. No, that's fine. All right, so we're going to reserve a slot. This is going to be reserve space on the stack for local variables or variable. That's sort of the idea. And I just want to see what breaks when we do this, right? So a lot of, it's not even going to run, right? Yeah. Okay, interesting. Let's build it. Build, there we go. And we'll run it here and see what happens. Okay, we're in an infinite loop or something. Where are we? Oh, interesting. Oh, I see the problem. I didn't save this file. So it was trying to parse all that text that I had up there, and it just didn't know how to do that. So yeah, that's not good. What about now? All right, so we do get a program. Looks like this, and looks, yeah, we've just allocated these onto the stack straight away. That's good. All right. Let me look at the C code. I'll zoom in for you guys. It's a little bit too small. Can I zoom in? There we go. So here's the C code. So this is kind of interesting to me. They're moving into RBP -20, but they don't update the stack pointer. Is that handled automatically in this type of assembly? Because I'm pretty sure on the Windows one it's ignored. The base pointer is ignored. So maybe this is the sysv GCC x64. Okay. Yeah, I'm not sure. Like if I look for MSVC, you can have a look at that. Here we go. I'll just do the latest, I guess. Use of this compiler is only permitted for internal evaluation. Okay. So what does this do? See, this subtracts from the stack. That's the shadow space. Then just moves into RSP, the value 40 and 2. And then add to the stack pointer 24 at the end. That's correct, right? So the question I'm asking here is, do I even need to manually sub the RSP? Maybe in NASM I do? Not sure. All right, I'm going to put that as a question that we can maybe answer in the to-do. So, question, do we need to manually sub RSP when values onto the stack? It seems that both MSVC and GCC on Unix do not. All right. Cool. So, call add, and okay, so here's the problem. Right. Now that we've stack allocated these, we want to call add. Oh, actually, that's not a problem. We just haven't fixed this. Exit Y. What does it do? Moves into, yeah. So this is the issue that we had last night. So now it's trying to move into none, the value from here, from this part of the stack, and then also the value from this part of the stack. So let's have a look. Where did we do that? Where do we? I think it's here. Because there's a to-do, get from stack. No, this is the parameters, not this one. And it's going to be this one. Yeah. So I'm going to undo this debug trap. I'm going to build this so we can have a look at it in the debugger. All right. So here we are. We've got our symbol, which is an X. It's an untyped integer. That makes sense. Right. So we have no type coercion. Maybe I shouldn't try to mix these two concepts right now. So instead, just to make it a bit more concrete, we'll change these to U32s. Really need multiple cursors in NeoVim. I heard it's happening soon. Anyhow, now I've got U32s, so that's good. Okay, so we're going to look at this, and we're going to say if it's an integer type, register is blah, blah, blah. Okay, so that was probably the problem before. This is returning false, this is returning false. So let me look at the code that we can generate with this. Okay, it got stuck. Oh, because there's a trap. I wish I could, maybe there's a way to do this. Is there a flag I can pass so that it skips traps when I do Odin run? Ignore system calls. Show timings. No type asserts. No entry point, no bounds check, no CRT. No. Did you mean limit? Yeah. Max error count. LTO, no. Keep executable. Ignore unknown attributes. I should probably just pipe this to RG and search for trap. Okay. Well, there's that one. What about runtime? Okay, foreign error procedures, dynamic map calls, source code locations. Doesn't look like it. I guess I could wrap this in a when When what? Because I don't know. It's fine. We'll just run it. I'll just comment it out. It's kind of annoying. I need to figure out how to do that though. Excuse me. Okay. Well, that's correct. Look, we're moving into RCX, the value, and RDX, and then if I actually run this code, we should get 42. There we go, 42. All right, so this program now runs, but as I was saying at the beginning, it sort of runs by coincidence because these variables and these variables are the same variables because we have no scopes. All right, so I guess I'm going to mark this as done. We are stack allocating all locals. That's good. I don't have whatever symbol I need to show these nice to-dos or whatever, but that's fine. Create some kind of data structure to store scoped symbols. So I haven't thought too much about this yet, but let me think. We're only ever executing one scope at a time on a single core, right? And so I guess it would be thread local variables for one thing. I do want to support multi-threaded code, but I guess right now I probably shouldn't think about that yet. If I try to think too far ahead, I'll make something totally wrong. It'll just be the wrong API, the wrong shape. That's all right. We'll just have to rewrite stuff as we figure things out. But so for now, I'm going to delete this, run this code again, put add at the top. All right, that still doesn't work. That's good, I guess. Why doesn't it work? This was working yesterday and broken. Now it does not work. Which order did they get compiled in? Add is at the bottom. Main is at the top. Yeah, that's right. So what do we actually do here? We move these values onto the stack, and then we didn't move them into registers before the call. Huh. Why not? That's a bit strange, isn't it? Oh, I think I have an idea. Probably because we couldn't find the procedure. Where is it? Call. Use registers is nothing. No, that looks fine. Hang on a second. Call arguments. So we don't even do type checking, so nothing in here that should break that. Why does that not add anything? Oh, because there's nothing in the arguments list, so it doesn't get added, obviously. Right, and because it doesn't get added and we don't store them in RCX and RDX by default, now they're on the stack, this doesn't work anymore. Well, that's good. Now, we probably want to... I mean, that's good. Technically, these still exist in the same scope, though. So, it's kind of a problem. Let me think about this. I got to do some sketching. So we've got a scope. This is our scope. This is our main scope. We've got variable A, it's 42. Now in here, we could have B, which is 20 or whatever. And of course, down here, we try to reference B. It should say this doesn't exist. But currently, this is just going to get added to a global symbols map, which has no concept of scopes, right? Now, the thing I'm trying to wrap my head around is when I'm thinking about scopes and I'm thinking about assembly, I got to remember that when we when we're parsing the program, we're not running the assembly, if that makes sense. So when we're parsing the program, we're not running the assembly, but when we output the instructions, they're going to be sequential, which I think means we can just push to a stack a new symbol table every time we open a block, I think. So if we have a symbols table and then we have a stack, which I guess I can just make it a dynamic array of maps of symbols, but I might want to make it a, yeah, no, I think that would be fine. And then we need to check when we look up a symbol in the current scope, we can get A from the previous entry in this array, and then as soon as we exit the scope, we'll pop the end one of this array, right? And then B will no longer be, oh, but then B will not be visible anymore. Oh, that's correct. B will be gone, and then this will say I don't know where B is. Okay, that's what we want. All right. I just realized I personified that variable there. That's cringe. Totally cringe. Anyhow. So, well, what have we got? We've got block. Apparently the only place that we have blocks is in the file. That doesn't make sense. Unless I overloaded it. I probably overloaded it, didn't I? I gotta stop overloading things. But there is a block. There's a block struct in the nodes because I want there to be a return statement attached to a block, which is what we use for procedures. And also a resolve, but I haven't added that feature yet. But it's going to be a feature later. So you can resolve the block into some expression. That's sort of the idea. So you can have like x is, I mean, this is a stupid example, but you know, resolve 20 and then x will become 20. But you could do a series of statements and whatever you want in here, and then you could even do like an if condition. Now this seems a bit weird. So you could do something like this. Because this is an if statement, then the resolve will bubble up to the nearest block expression. I mean, block that has a variable, so a block expression, I guess. And then, depending on this condition, it'll be either 20 or 10. But then you could also, if it was just this simple, you could do something like this and make an if expression. But yeah, these are features that I want to add later. Just little convenience things. But now, let's try to get blocks working, eh? So B is 20. I'm going to put this up here in main. Actually, yeah, I'll put this up here in main. So I want this to error in multiple ways. Actually, just one way. I want an error that we can't find B. So what happens if we run this now? I'll delete that for now. Right, everything's broken because I changed the symbol tables. That makes sense. So if we go down here to add symbol, all right. So I guess we're adding the symbol to the current level. So we've got to get IR symbols, the last one. Oh, darn it. All right. So this is the table. -1. And I'm going to just simply copy this here. All right, so we add this symbol to here, and then I'll put a to-do, check for shadowing, and make sure symbols have scope. We're doing that now. So that's what this is for. Now, when we add a symbol, we also want to... Do we want to remove symbols? I don't think we need to remove symbols because it's going to be closing a block. So if we go block here, we'll say append ir.symbols with, I guess, an empty map. Can we do that? We'll see. And then pop back. I think pop back is the default pop for a dynamic array, but I can't quite remember. We could also do this a different way. Whatever, it's fine. I don't need this. Okay, it's going to be broken in a lot of places. Also, we can't do this, given the argument type. All right, so we've got to actually create the thing that it wants. So it wants a map. That's the type. Is that gonna work? Yeah, that seems to be okay. What? Oh, I scrolled up too far. Okay, I gotta clear that. Alright, there we go. Pop back. Pop back is not a thing. I guess it's just pop. Okay, assignment count mismatch, etc. 325. Here we go. So I'm gonna make a getter. Symbol exists, I guess. I don't usually make getters and setters, but in this case, it might be very useful as we change the way this stuff works. So we just want a name, and we'll just get it from any scope. So we're going to return a symbol, and whether we found it. And so what we want to do is walk up the scopes until we find a symbol, and if we don't find it, then we don't. Well, if we don't find it, we don't find it. So I suppose, easy way to do this, reverse for loop. Which I do like this reverse directive. It's quite useful. So for table in symbols, if name in table, do return table name true. Otherwise, return false. Is that going to work? Parameter name string is missing. Yeah, right. Okay. Node.token has no field name. Oh yeah, because it's called text. Okay, and then also I'm going to look at line 369, 375, and 377. Okay, so this will be another get symbol candidate. Well, say exists, I suppose. If it doesn't exist, then this should be a compile error. Alright, and I forgot the other places, 375. Oh, it's right here. Right, yes. So, what's wrong with this? Probably just cascade of errors, yeah. Alright, so we got an infinite loop again. Interesting. I wonder why that is. Do I even handle blocks within blocks? I might not even handle that case in the parser. Parse block. So I've got block as a procedure body, and that's the only place where, yeah, that's the only place we're handling it. So that is indeed a problemo. All right. So we need to look in, not in parse file, but I guess in parse block itself. So expect a left brace, and then if the token is not end of file or right brace, we want to check for any of these. At the moment, we're only checking for variable declaration, or something that starts with a word, like return, probably call. How is call not in here? Does that mean I can't even return? Weird. I guess we don't even handle function calls yet inside blocks. It's just we handle them only on the return statement. I do remember saying many times, let's just get our current case working. And this is what happens when you do that. And repeatedly, you end up with a lot of holes. So, right. Here it is. So, return parse expression. Aha. Okay. If it's not that, then... yeah, we actually can't just call a procedure like this. We just can't do that. It just won't work. We'll get that working later. So for now, if it's not a return, then what would it be? Okay, not an identifier. Okay, we can just put L brace. If it's a left brace, then we want to make a block. Let me look what make block does. It consumes a left brace, so I just want to pass in P, I guess. And then in.data.block. No. Parse block P. I think I don't even do that because we do that at the top here. Yeah, okay. And then at the end, all right. Cannot find identifier B. Hey, that's good. That's actually the error that we wanted. But maybe I shouldn't panic. I think what we should do is probably just error. Error F is not a thing. Oh, really? That must be a log procedure. I'll just print it then. Alright, cool. Cannot find identifier B. Probably printf ln. Cool. That's good. Now what actually happens with these scopes? So we move into somewhere to value 42, and then that's it. Well, I guess that makes sense because... no, does that make sense? That doesn't make sense. So we just don't do anything here, it looks like. It doesn't even get parsed. What does the AST look like? We've got a procedure declaration, a block. We've got an A and a C, and we've got no block here. Okay. But that could be because of the printing. No. All right. So this returns a node which we need to append. We didn't append it. Right. So we need to append onto hang on a second. No. Yes. So parse block makes a block. Okay. Fine. And it returns a node. It returns itself. Okay. So we'll just append it. Append it. Or root.data.block.statements. Yeah. Okay. Variable declaration, block, variable declaration. That's better. Okay, cool. I'll make these typed. Oops. That can be, yeah, I'll just make it typed as well. All right. So we're getting an error, cannot find an identifier B. That's correct. But what if we wanted to, well, let's just check. D32 equals A. So this shouldn't be an error. And then here we could have E equals A. What have we got? Cannot find identify A, cannot find identify A, cannot find identify B. All right, so definitely got some errors. This should work. And this one should also work. This one should not work. Okay. That's good to know. What? Did I do something wrong here? Let's just have a look, I guess. So we want to build this. And get symbol. Okay, I can't go there. I can search for it. Next. There we go. That was at the end of the file. Didn't need to search. Anyway. Alright, so currently we are trying to get the symbol for the variable A. Okay. So if we look in the symbol array, there is two. Two maps in there. There are two maps. Yep, IR symbols 2. Okay. First one is apparently empty. That's not good. What about the second one? Also empty. Okay. Did I not? Yeah, that needs to be a pointer, right? I just copied it into the local variable. Let's try that again. Okay, now we actually have symbol tables that get updated and created. Good. One hit. Oh, yeah, right. All right, so let's have a look and see what happens with running. Okay, did we get errors? Okay, cannot find identifier B. Correct. That's good. Now, are these correct though? Let's have a look. So, it doesn't look like there's enough code. There should be 1, 2, 3, 4, 5 locals. But we've only got 2. 42 and 20. Well, I guess technically if E is just A, we don't need to assign any space for it. But I think we should, because that's what that should mean. It should mean I want to make a copy. Alright, that makes sense. Not just I want to store this in a symbol table. So, where did we do this? Here, I suppose. Right. So if the case is an identifier, right, but what about if it's an assign? No assign? These are, what are these, Vardecal? Vardecal. Okay. So there should be, in this case here, a slot for E, but it might just reuse the same slot as A, which is not really what we want, because that's making a pointer to something, and then also not giving you the address. So where was that? What line? 230. Line 230. There we go. Oh. All right. So we're making a variable. It is which variable? Doesn't tell me. A. Okay. I thought so. Next one. B. All right. We don't care about that one. I just opened RenderDoc by accident. Anyway. Okay, here we go. So this one should be E. Yeah, so E is saying, yeah, so E is saying, oh, hey, I'm actually the same thing as A. So you can just add in the symbol table that E and A are the same place. That's not what we want. How do I not do that? At the right-hand side. So we lower it, which means we call on the expression. And if the expression is an identifier, it tries to get the symbol first and then returns it. But do we want that? I don't think we want that. Because then it just fails otherwise. So it tries to get the symbol, then returns the symbol. But I think what we need to return actually is a slot for the other thing. Let me think about this. So this is the right-hand side. Maybe we just need to reserve a slot here. Reserve slot. Okay. But then where does this go? Oops. Darn it. Okay, I'm going to close this. I'm going to simplify this code, not worry about scopes right now. Okay. I'm going to run it. All right, so what we get is create space on the stack to put the number 20, and then that's it. The problem is, if we're assigning one variable to another variable, yeah. So we lower the expression, and then when we lower it, I feel like we need to know whether we're lowering a R value or an L value. Hey Ian, how you doing? Ian says it should return a slot that has had whatever's in the left-hand slot. No? Question mark. I don't quite know what that means. I think that's the current behavior. Has had the left-hand slot copied into it. Yeah, copied into it. Exactly. That's what we're trying to figure out. That's the bug, yes. Yeah. So basically we want to make a new slot for E and then copy this value into it. But the problem is the problem that I was running into earlier was I was ending up with multiple allocations, one for A and then one for the value of A, and then one for E and then one for the value of E if it was a number. Instead of it being A is stored here, it was like ending up in multiple places. So I got to think about this for a second. So I got the variable declaration. We got an expression. Seems like it should be a special case, but that doesn't sound right. I don't know, says Ian. Yeah, maybe. Maybe it could be a special case. I'm not sure. Well, I guess we'll find out. So variable declaration has a type and an expression. Interesting. And then the name is just the token. There is already a lot of special stuff around variable declarations, like for untyped integer, untyped float, etc. So I've got to also test, I guess, something like 40 plus A, and then 40 plus 2. That's not the right command there. So 40 and 2. They get added to the stack. But then, wait, 40 plus 2. That's these ones, I guess. 40, and then this is incorrect. This doesn't even compile. Again, because we're trying to add together something that's on the stack with something else that's on the stack. Yeah. I feel like I had this problem yesterday and I solved it and now I've broken it again or something. I'm not sure. Alright, well, we'll concentrate on this case first. Try to get this working. Okay, so we need to create a space for E if we're copying a variable. So what happens? Let's trace it down. So we lower this expression. The expression is simply an identifier, which means we then run this case here on the right-hand side, and we get the symbol and we return it. But that's not what we want, because we didn't make a space for it. We're just returning the symbol operand itself. So I guess what we need to do in this case is know if we're on the right-hand side or the left-hand side. And if we're on the right-hand side, then so that doesn't make sense either. Hmm. Ian says, I feel like it shouldn't be a special case in the lower function, but at the code gen places. Right. Well, let's have a look at the AST. It just says E. Maybe you're right, actually. So E is a variable declaration, and it's assigned to A. Yeah, that's a good point. So let's have a look at the emit. So when we emit a... There is not even emit variable declaration. How does it even get emitted? Dun, 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 dun. There's a move, procedure declaration, div push, pop, ret, call. Well, I guess the problem is... Okay, we add the symbol, and then... Right. Well, let's look at the IR. Right, so we've got... Where is it? Here. So this one is allocating stack space for 20. Right, this one is allocating stack space for... Yeah, allocating stack space for the next variable, but then there's nothing after that. So we move the immediate value 20, and then there's nothing here. So we do need it in the intermediate representation, right? We need it to show up after this, before this add, because this is returning the stack. So we need to have it show up under this one, right? So this one says we're going to move the value 20 somewhere. Is the variable declaration lowered again somewhere? Question mark. I don't know what you mean. It seems like it's turned into an actual stack allocation somewhere. Yeah, that's intentional. It is a stack allocation. That's right. Yeah, I'm doing all locals are going to be stack allocated, just like C does in debug mode. So you can see here, 40 and 2 both allocated onto the stack. Apparently it's better for debugging. So I got rid of the register use for locals for now. Maybe that can be optimization later. All right, Ian says, I mean, obviously it's stack allocation in the IR, but where is it turned into that? Right, you mean where is the lower case for this? It's in the place you currently are. It looks like a symbol registering. I might have missed something. Well, it's recursive, right? So it's here. So we're going to lower the expression, and then the expression is an identifier. And then, oh no, that's a good point. Yeah, where is it? I think I probably loop over the symbols. Where did I do it? Not here. No. Block statements. Ian says you need to change the assign expression. Why would I need to do that? Oh, because this is an assignment? This is a variable declaration. Let me see. Where is it? Procedure statements. I can't actually remember. So it's got to be a make binary somewhere, right? Make binary. Oh yeah, it's here. When we do stack alloc, here it is. When we do stack alloc, when we reserve a slot. Okay. So when we reserve a slot, it does stack alloc. What else do we call stack alloc? This is for padding. When we reserve register, I think that's what I've called it. Why do I have reserve register and reserve slot? Oh, because I was doing both. Yeah, that's right. So I guess it's here. Ian says, doesn't seem like the IR has a separate variable declaration instruction, so I'm just assuming it's an expression. Right. All right, let's have a look. Well, here it is, reserved slot. Ian says, normally assignment is an expression in things like C. I mean, I don't know what you mean by assignment. There's no assignment here. Assignment would be E equals 42 after it's declared, right? Or whatever. And then that's an assignment. A equals B is a binary expression. Okay. The type is just an addendum for the type system to check if it's correct. Right. Okay, let's have a look here. So, when we lower this down, we get a slot back. The slot is... like int a equals 0 is just like declaring int a and then a equals 0. They aren't coupled, only in the syntax. Oh, I see. Oh, right, so I'm coupling the concept. Is that what you're saying? Like in my, whatever, semantics, the variable declaration is actually this whole thing, and then the right side is an expression. So this would be right-hand side here. That's basically what this is. But there's no... First it allocates and then it sets separately. You seem to have coupled it. Right. I see. Right, okay. So what you're saying is, if I understand correctly, it should be, or if I'm going to follow the conventions, it should be a variable declaration and then a binary operation, which is assign. 2 steps, not 1 step. In this case. So a variable declaration would be, yeah, just, so this is the variable declaration here, and then there's no binary operation part. Yeah, okay, interesting. Right. Okay, I see. Well, let's have a look at the tree. So variable declaration number 20. Right. So if we were to follow that convention, then when we're parsing this, creating a variable declaration, rather than consuming the assignment operator, we might want to create something like, can I just get something to draw with here? We might want to create something like equals. I'll just put equals. And then it would be name on one side, and then on the other side, expression. Name equals expression. And then prior to this, it would be... Oh, hang on a second. I did something to the chat. What happened? How do I get out of this? 1 second. Just a second. All right, there we go. The AST is correct. It's just that in the IR lowering step, they would split the two. Okay, so we don't have to actually change the AST. We just have to separate the concepts in the variable declaration. All right, so let's see. If we just comment this out for a second, just think about it from first principles. We've got create a symbol. But I guess create a symbol on the create space on the stack and bind the symbol to said space. Then on the right hand side, see, the problem is now on the right hand side, are we going to create space for that on the stack too? I don't know, that seems weird. It seems like double. Actually, let me just have a look at what C does. Give me a second. So what if we do this? Int z equals x. What does it do? Okay, now it's copying x into a register, allocating space on the stack, copying the value from the register into the stack. Right. Allocate variable, oh sorry, Ian says allocate variable and register symbol, then lower a brand new fake expression. So that's basically this. Right? Okay. You would create a new expression node just for the assignment in this case. Right. Yeah, I would rather modify the way the AST is built than make a fake node at this stage. That seems... But maybe the wording that you just said isn't exactly what you meant. All right. So, okay. So let's say we're doing A is B. Actually, just whatever. A is 20. Create space in the stack. Bind a symbol to said space. Ian says Abdul might have been able to explain it better. Lol. Maybe. It's not your fault. I just don't have a clear grasp, and I need to sort of understand things in my own terms, if that makes sense. I have a hard time understanding what people are talking about pretty much all the time. So, let me see. Create space on the stack for... Okay, we'll do this one first. Just x equals 40. Also, I should change this to... What's the default? GCC or something? I guess it doesn't matter, it's already on this. Ian says, but I think compilers are just complicated. Yeah. Yeah, a little bit. That's okay. This is what comes with the job, right? Just gotta try until you understand things, and then it will be easy after that. So, in this case, just allocates on the stack the number 40, but in this case, we create an we move it into a register, the value. I'm just trying to wrap my head around how it did this. Let's see. What if I get rid of this? Ian says one thing worth mentioning as well is that having only one lower function that does everything is making it harder to reason about the code. I think you'd have to be more specific about why it's making it harder. So in this case, x is uninitialized, right? So this is just going to be nonsense. Okay. All right. Let's see. So create space on the stack. Bind a symbol to said space. So that's basically this. That's this case already. It already does that. But, right, that's this. Makes sense. Ian says, all the compilers I've seen have multiple modular functions for any given compilation step, like you have in the parser for expressions. Oh, yeah. Right. I see. I mean, yeah, I suppose that's something. I mean, the step is just what part of the switch statement are we on, right? So it's not really different compared to having a function. Unless we need to do some bespoke thing and return different values and stuff, but yeah. Okay, so this part already works. The problem is, with this, I'll use the same example. E is A. Now what we need to do is copy A into a register from the stack, and then assign or move value, create space on the stack for E, and then copy value into stack from register. So I guess the part I'm trying to figure out here is, you know, this, let me actually see what happens if I do this 20 plus 2. What is this output? This output's nonsense. So this doesn't even work at the moment. Expressions on the right hand side doesn't even work correctly. Okay, so that's something to take note of. It does allocate 20 and 2 correctly, but then add is looking up in the stack. So then we've got to know if we're on the left of a binary operation, right? The source, or the destination rather, then the destination can't be the stack. So if the destination is a stack at this stage, I guess, Ian says you do like, I'll just type it out here, lower IR the expression of a slot a dot expression equals usually. And Ian says most compilers I've seen just create a fake nodes willy-nilly. It's not a problem unless you want to output 1,000 lines of code a second or something. Well, I do want to output 1,000,000 lines of code a second, but that's not the goal right now. The goal right now is to get a working compiler. Right, expression of, okay, so it just makes a new expression. Right, I see. Well, anyway, that's cool. Maybe I'll end up with that shape later, but I'm just going to do things this way for now. So what we get back here, I just want to do a 246. Let's have a look. So we are looking at, what is this? We're looking at an add. So that's this. We're looking at this expression here. Okay. Right. And the destination is on the stack. All right. Interesting. And then basically what we do is output this instruction here. So the problem is, I mean, this is probably not how we're going to end up doing it eventually, but if DST is on the stack, that's invalid, invalid assembly. So we need to put it into a register and then copy back to the stack. Ian says, I might drop onto your Discord later to explain things a bit better because the character limit here is not helping, if that's okay. I mean, yeah, sure, feel free to drop in anytime. That's fine. So, I'm going to say if the destination register is RBP, then this is a stack variable. I'm actually going to make this a Boolean. Wouldn't that always be the case? No, I don't know. I think it would always be the case. But anyway, if is DST stack, then we want to, this is where we actually want to get a register. Reserve register. That gives us a register and a Boolean. If it's not okay, do something with an error. Otherwise, we need to then unreserve that register. So we need to know which one it was. And now that's not going to work. Alright. So we got the register that we need. And then we're going to, I guess, temporarily change the destination. Yeah, this is definitely not the right shape, but that's all right. Okay, just going to do something simple. Well, maybe not that simple, but something I can get my head around right now. For this, so we got the destination copy, register, and etc. And now we're going to say append. No, not append. I'm just going to make binary instruction, which is a move instruction into the register. And we're going to move. What are we even moving? Oh, God, I forgot what I was doing now. I think we're moving the destination, right? If DST is on the stack, that's invalid. We need to put it into a register and then copy back to the stack. Okay, so we're putting DST into a register. But is that what we wanted to do? Yeah. And then DST in this case is going to become a register. Then we can add something. The destination is a register rather than the stack. Okay, and then at the end we're going to have to undo this. So welcome in Summer, or Summer WTFE. Summer says, just had to watch your legendary LDTK video again because every time I have to use it, I forgot everything. Oh, cool. I'm glad you're enjoying it. Glad it's useful. It didn't get that many views compared to my other videos at that time, but it's nice to know that it's helped someone. That's good. All right. So now we need to copy back. I gotta look at what this produces. Trying to hold too much in my head. Oh yes, of course. Okay, so we're gonna move this into RCX and then add into RCX this value, and then we copy it back to this location. That's what we need to do. So it would be copy DST, I guess. Move into copy DST. The value that's in the current register that we just used. What's wrong with this? I keep forgetting to add the state, and that's not, oh, it's called DST copy, isn't it? All right, now we're going to move back into here, the value 2. What does that actually give us? Interesting. So we've assigned space for 20 and for 2 rather than for the result of 20 plus 2. As if they're separate values. Let's see what C does. And I'll have to fix that other issue as well. Ian says, one thing that might also help is to have a platonic ideal assembly program that you write beforehand so you have a better idea of what your compiler should output or close to it. I've seen people doing this before. That's kind of what I'm doing with this C program here. So even in unoptimized C, it does the addition at compile time here. So that's... How can I make it not do that? I don't think I can. Because why would you not just add these together at compile time? Obviously I could make this a variable, and then I guess we're combining the two problems that we have together. So let's see, we make space for 2 on the stack, then we copy into this register the value 20, then we make space for X on the stack. No, then we copy X. Where's the... Oh, add is here. Okay. Make space on the stack for 2. Very good. Okay, interesting. Alright, I'm gonna change this a bit here. Let me get rid of this, get rid of that. So we can just look at the really basic. So this is basically what we want. Something like this. It'll be a little bit different, but let me change this to GCC X64. There's too many compilers. I'm just sick of looking at this syntax here. There we go. All right. Okay. So I want to be looking at something like this. Making space on the stack for the value 2, moving into EAX that value, adding 20. So let me do exactly the same thing here. So I'm going to even call the variables the same thing. So we've got y equals 2. I don't need equals x equals 20 plus y. Okay. Now, right. So that's some setup that I always do no matter what, which maybe you don't need to do. But anyway, regardless, allocate space for 2, but then we also allocate space for 20 when really we should just be adding them together. All right. Just going to copy this. This is our target. I can't even remember what the stream was called. I think it was called Scopes. And we did the scopes, actually. The scopes are working, I think. So that's successful. But yeah, we need to make expressions work properly. So variable declaration. Yeah, so we need somewhere to put the variable, which is the result of what's on the right-hand side. But I guess the problem I'm having wrapping my head around is like, what happens when we start doing more complex expressions here? Let me just do it in the C compiler. Times, 40 divided by 2 plus, and then you could even do like a function call, but I'm not going to do that. I'll just say C. Ian says, one thing I've been meaning to mention is that you should look into basic blocks as a means to make stack operations easier. Should also help with branching and dead code elimination in the future. Something to check out later. Basic blocks. Okay. All right, so interesting. So we can hover over this operator and it shows us all the lines associated, but then nothing with these ones. All right, so what are we doing? We allocate space for 2 and 1. That's all good. Then we start doing an expression. Okay. Load effective address. RAX plus 1. What? Oh, yeah, because we're doing a divide. I'm going to remove the divide. The divides are going to make it more complicated, and we don't need to do that. All right. Okay, so 20. Hang on, it's still doing a load effective address. RAX plus 20. Calculates the memory address specified by its source operand, stores that address in a destination register without reading or writing to that memory location. Okay, base plus index times scale plus offset, no memory access. Ian says, another thing that makes my head spin is the RAX, EAX, AX, AH, AL stuff. Right, yeah. Well, luckily we're just dealing with 32-bit here, so it's mostly EAX and etc. Might be an optimization thing. I'll turn it off explicitly. Yeah, you're right. No, it's still doing load effective address. So why don't I get rid of the multiplication? It's still doing load effective address. Weird. I wouldn't have expected that. So what's actually causing that? Oh, that's cool. There's actually a thing that tells you in here. The address size, blah, 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 etc., etc. Ian said, this is why I mentioned making your assembly program yourself, because compilers tend to do some really weird things even with no optimizations. Right. Yeah. Yeah, okay. I mean, I guess as long as I get the correct output, it doesn't need to be one for one with what a C compiler would do. So maybe trying to reverse engineer what is happening here. I mean, it will definitely help because I'll learn, but yeah, I really got to pee, but I need to break this down into simple parts here. Stuff is made by wizards, essentially. Yeah, well, I guess once you get to, past a certain threshold of knowledge, you can see more of the shape of what's going on, and then you can be like, oh, it's totally obvious that you should do load effective address here. But for me, I'm just trying to add two numbers together on the right-hand side of a variable declaration, right? So, yeah. What do we got? 2, 20 plus y. All right. So loading 2 into the stack, loading 20 into the stack, moving into RCX 2, adding into RCX 20, then moving into 8. Wait. 20 plus y, 20 plus y, 2. Okay, so this is moving into the wrong destination, right? So this is moving, it is adding the numbers together, 20 and 2, which is nice. But then it's moving it into y, if I understand this correctly. So if I actually return x, well, invalid combination of opcode and operands on line 23. Let's have a look at that. Oh, get out of here. Ah, so this is just broken. We can't return x. Can we return y? No. Because it doesn't know how to find that. Ian says, might be something like the Quake R square root, where they use a random constant load effective address from an REX with a value set by EX. Might do something that results in 40 minus 2, I guess. Yeah, I don't know. Not sure. But we have a good thing to look at here, which is why is there no right-hand side to this operation here when we return? Let's have a look. Returning an expression. Okay. So we're lowering the expression. And that's going to be an identifier, which is here. If it exists, we should get the place that this identifier is stored. So let's run this through the debugger. I finally got somewhere to look. So we're going to look at return. Ian says, on a more positive note, it seems like you're in the right direction with the expression lowering thing. Well, I hope so. It's a bit janky, but that's alright. Jank is fine while we're learning something. We can always clean it up later. Slot. I actually really enjoy refactoring code, which I know some people might not enjoy, but yeah. So actually getting back an invalid slot here. Does it say that? When we run this code? Yeah, cannot find identifier Y. That's weird considering it's right here. Huh. So what's happened here? Something has removed the identifier. Or if we look at identifier, where is it? Here it is. Get symbol, so it can't find the symbol. So I guess we should look at the symbol table at this point. We're going to go into here. It's going to go down to the identifier. Let's look at the symbols. Not symbol, but symbols. Okay, I'll just use the watch window. Okay, somehow there's two scopes. I guess the file scope and the procedure scope. Yeah, that makes sense. Okay, and if we run this line, it does not exist, apparently. So what were we looking for? We're looking for Y. Apparently Y doesn't exist. Which is strange. So what I'm going to do is when we add a symbol, I'm going to print it. Added symbol to table. I guess I'll just print the pointer. Just so we can differentiate it. And then I will, actually, I'll just run the code first. So that should be up here somewhere. Ah, I didn't use printf-ln. How many times? How many times, old man? How many times? All right. Added symbol X to this table. Added symbol Y to this table. Now look. Turn on Windows Backup. And you can't choose no. You can only choose... Well, you can choose no, but remind me again in 1 week or 30 days. So obnoxious. Anyway. So, added Y to this table, added X to the same table. So they should be in there. Right? But then it says cannot find identifier Y. Right after that. So there's something wrong with this. Okay. For table in IR symbols, if name and table, return table name true. Ian says, thank God I stripped almost everything out from my Windows. I have not gotten those kinds of pop-ups ever. Oh, that's nice. I should do something like that. There's so many unnecessary things in Windows now. Also, just the... It's really annoying, but when you press the start button and you search for something, like sometimes I'll press the start button and I'll type an executable name that's on the path. And I'll press enter. And it won't have loaded the path fast enough, so it opens a web browser. And opens the search. Like, how is it? Like, you can just do it here. You can just open anything in here. Remedy... I don't have Remedy BG. Whatever, do I have code? Yeah, code. Or whatever. You could just type it right here, press enter, it would open straight away. But in the start bar, this thing, it just doesn't work fast enough. So you gotta like wait a second and make sure it's all loaded. So you could also, instead you could use this one, this run. Probably smarter to use this one. I think they haven't touched this in a while, so it might still be okay. So what exactly is the problem here? So we're getting a symbol, but we might not be getting the symbol. We're not calling, return, make binary. Yeah, we're lowering the expression. The expression is simply an identifier. But somehow, we're getting back that the symbol doesn't exist. Okay. So what I'm going to do is, if the symbol fails to get looked up, I'm going to print the whole symbol table. I'll print it in, yeah, whatever. Table in symbols for KV in table. And I suppose I'll do something like this. Print F space, 2 spaces or something. Okay. Is that going to give us all the values? Well, I need to actually do that. And this is going to be a V, I suppose. All right, so that might give us some more indication of what's going on. Or not. What? Hang on. Gonna find identifier Y. But then it didn't print that anywhere. Didn't do this. Cannot find identifier. So get symbol failed. It didn't print this. Am I blind? Maybe I'm being blind? I don't see it anywhere. Nope. Nope. Huh. Okay. I really have to pee. I'll be right back. I'm gonna get another drink as well. Huh. Hang on a second. Is the stream even live? It's like frozen on my screen. Let me just make sure it's looking good. Okay, I think it looks all right. Dosh Plays, welcome in. Please teach me C programming. I have a test at 1 p.m. today. I'm sure your test will be fine. C programming is easy. Cool. Okay. Alright, now we definitely just want to run this in the debugger. We want to find out where we're calling get symbol. Okay, I need to... Oh, thanks, Ian. Just remove that. Sure, Ian, go ahead. You can ping me on Discord. I don't have it open on this computer, but I'll check it when I can. Huh. Interesting. So, we call get symbol at this point. The weird thing is, it doesn't exist, but let's find out why. Alright, so what is the token? Actually, what's the node? Node is an identifier. Y, column 17, row 3, that's this one. Okay, I think this one is fine, right? Yeah, this one is fine. What about the next one? Alright, so this one, this node is Y, once again. However, why am I in memset? Okay, there we go. Get symbol. Alright, so we didn't find the symbol, apparently. There's no symbols. What? How is that possible? So, somewhere we deleted the symbol table? It's got to be when we exited the scope. Let's have a look at that. It's got to be here. Because I think... okay, so this is popping a symbol table, and then after the block, it's probably doing the return. Which is not what we want. So the return is a statement inside the block, but I think that's actually procedure declaration. I think that's, if we look at block, where is it? Here. It's actually a special node attached to the block. So is every block going to return? No. Not. But every block is going to close scope. So we can't put this here. We can't put this here. I'll think of a better solution for this, but for now, I'm going to put it after the return. This is meant to be... Actually, maybe this is fine. No, this is not fine. This should be relative to the scope being exited, not right now. Ian says it should be fine to pop from scopes after the block is lowered. This is what I was talking about with coupling return to a block/function. What do you mean it should be fine though? I mean, it's obviously not fine. What do you mean in an ideal world? Okay, so that's correct. Great, this is working. So what you're talking about with coupling return to a block/function. Right. So, I mean, after the block is done lowering, you wouldn't need the symbols inside that block. Question mark. Yeah, that's right. Yeah, that's right. So yeah, the problem is, as you were saying, that return is its own thing on the tree here. Can't remember why I did that. So if we look at a procedure declaration, it's got a return type. That's fine. But then block has a return node. Yeah, so this should just be a statement. That's what you're saying, right? Let me have a look at this. No, I can't search for return. What am I doing? Yes, it should be a statement. It's fine. There is only one return statement per block, and it's always at the end. So how does this even get called? We've got to lower it somewhere. When we call lower on a block, it appends to the symbol table, right? Okay, I'm going to remove this from here because it really shouldn't be here. I'll put it back here. It really should be like this, and then we should have... Ah. Where did I have that? Ian says, I think you removed the ret lowering because it used to be after the block. Right. Okay. No, here we go. It's right here. It's in the... Oh, that's the problem, I think. Right. So we're just... Oh, because I always wanted to have a return. Where is this? This is like procedure declaration. All right. Yeah. Okay. Okay. So in a procedure declaration, at the end of the statements, there might be a return. But also... Procedure declaration... Ian says, yeah, you coupled it to the block, but the return lowering happens at the function lowering. Yes. So... This is a block, right? So we've got the parameters, and then... Here it is. We lower the block. And then by the time we get to the return statement, we've already exited the scope. I mean, we've added all the... created the variables, etc., and then popped the scope, and then we do the return. So that's sort of not good. Right. Yeah, this should just be a statement. I should just not have this in here. Ian says, usually there's a ret statement always emitted at the end of a function, and all the return statements just jump to there with a label. Oh, yeah. Well, that makes sense. Right, I see. Okay, let me have a look at the assembly. So what we want is... No, this is the correct assembly. I need to break it again. Alright, now it's broken. Add these numbers together, etc. But now we don't know where the Y is because we've lost the scope. And that's literally because of this. Yeah, okay. I'm going to delete that. All I'm going to do here is I'm just going to append to statements. What does this look like? Doesn't even work. Dang nabbit. Right. Of course. Okay. All right. Yeah. So now the problem is we've got to figure out at this point, and we don't have to figure anything out. We could just do this before the return, right? So when we're lowering a statement, if we're going to return, we have to do this part. Ian says, but they would do stack deallocation at the end of any scope with the final return deallocating any function scope variable. So you'd need to keep track of that with any return statements inside blocks and such. Yeah, that's the problem we're running into right now. Okay. Yeah, we're going to run into an interesting problem here very soon, which is when we add nested scopes. Ian says, when you push a scope, you should also store the current stack size. Yeah, that makes sense, because then you can tell how much to reduce when you pop the scope, right? What did I even call it? Symbols. Right, so I'm going to call this push scope. Actually, if this is the only place we're going to do it, I don't need to do that. But we may want to wrap this, rather than a map to symbols, it could be, actually we could just call this scopes. Stack offset. Ian says you can just store it locally in the block lowering. That's true. We can just make a local variable. I'm overcomplicating it. It's a good point. So the diff would be this, and then pop the symbols and stack deallocate the difference, right? Okay, that's not a thing that we can do apparently. I think I need to pass in this. Okay, so what does that look like? And Ian says, never mind, you need to keep the stack size for return statements. Sorry, lol. Right, so we got the return at the end. Yeah. Right, because the return is now a statement. We need this. But because we're parsing things sequentially, okay, I'll go back to my overcomplicated solution real quick. All right, scopes. Whoops. All right, stack offset at outset. No, if this is nested scopes, then we can just compare it to the previous one. Okay. I want to push a new scope, which is going to have, I suppose, symbols is just an empty map. And stack offset is IR.stack offset. Now, we get the scope back and stack deallocate. Yeah, this should work, I think. Of course, I forgot to pass in IR as usual. Yeah, this is all broken because that's not how the symbols work anymore. Okay, so it's IR dot scopes. Ian says, sorry if I'm backseating too much. No, that's all good. It's useful. Just know that I might not always take your advice just because, you know, we think differently, so. But you've been helpful so far, so thank you. 111. This is not good. I'm just going to delete this. Okay, so when we add a symbol, scopes dot symbols. Yeah. $5.93. Yeah, I've got about 50 minutes left until I've got a meeting I have to attend. What's wrong with this? Doesn't like that. Cannot iterate over a table of type scope. Oh. Am I on the wrong line? I'm on the wrong line. Gotcha. Okay. What do we get up here? I feel like... I mean, obviously these are in the wrong order now. Because we've got to... We're doing a stack allocation... Wait, we can't do it here. We were just talking about this. We've got to do it when we return. So anytime we return, we pop the scope. But also at the end of the scope, if we didn't return. That's kind of... Wait a second. Let me just look at this. I'm going to do something really stupid here. If we... It's fine to have it twice. Ian says it's fine to have it twice. Why is it fine to have it... Oh. Because the stack offset will be the same, and then it will deallocate 0. If the return is a jump, it will ignore the second dealloc. Right, but we're always popping the scope, so... Oh yeah, I just shouldn't do that twice. I can deallocate it, but I can't pop the scope. Scopes, len. It's not what I wanted, thank you. Alright. That works. I think. Let's see. 8, 8, 8, 16. Not quite. Why are we moving into the stack? Oh yeah, because we have to restore it later. That's fine. Can I even just simplify this even further? Ian says, yeah, since the return is either a jump or the actual return instruction, anything below that will just not run because the function terminates. So not popping the scope at the return is fine / correct. Yeah, I just got to make sure that the... I mean, obviously this is not working because it doesn't understand how to return y. Because, what, y doesn't exist? Maybe? Let's see. So I need to look at get symbol again. Okay, so where did we just come from? Return. Yeah. All right, so get symbol. Okay, it found the symbol. Y does exist. Okay, that's good. So let's have a look at that. Y exists, and it's currently on the stack at offset 8. So we return that. And if it's not a call, then we move into RAX. How come I don't see that here? Oh, it's here. Okay, it is here. Move into RAX. The value that's on the stack, offset 8. Then increment the stack pointer or increase it by 8. So I think really the problem here is that we're not deallocating this 8 from the stack for some reason. It's probably hard-coded. Let me have a look at this. Emit. That's fine. Where's call? Call is just call, and procDecl is just label. Okay. Let's have a look at the IR. So we are generating procedure declaration means what? Nothing? That's right, it's just an empty operation to make the label. Then we've got, okay, allocating 8. Ah, right, yeah, because I deleted all that code at the end of procDecl down here. Stack deallocate. There's not a leaf, then deallocate this much, but that's after the return statement. So this needs to be do this before any return statement, really. So we can't actually have stuff after the body if there's return statements in the body somewhere. Yeah. So we've got to no, it's not deallocating correctly. Because we need to deallocate 16 bytes, but it's deallocating 8. Yeah, I'm not worried about this one at the bottom, that's fine. It's just, this is incorrect, so let's have a look at return. Actually, I know what the problem is. When we do procDecl, we allocate the shadow space, or, where is it? Yeah, right. So we allocate if it's a leaf, we allocate 8 to, what's that for again? Just store the return address, I think. But I think call should do that. Does call do that? Yeah. No, it doesn't. So I think that's maybe the problem. So we were generating correct assembly with this before, but perhaps now this is not the best idea. So the problem is we're calling procDecl, and then at this stage down here, this is when we create the scope, right? Because we're lowering the block. And so it's saving the stack size after we've done this. So I'm just going to comment this out for a second. Okay. It's still broken, but at least it's deallocating the correct amount of stack space. So here we're just copying RBP straight away without, we can't do that. That's going to break everything. But oh yeah. Oh yeah, so we wanted to allocate space to save RBP because it's a non-volatile register at the beginning of every procedure. But technically this is before the scope starts. So what we could, oh God, it's kind of annoying. So really, why did that not work? Oh yeah, copy into RS P-0 RBP. Ian says, it seems like this should just use push/pop RBP with the epilogue thing I mentioned earlier. We can try that. We can try that. For sure. So, I don't think it'll solve the problem, but maybe it will. Alright, so push RBP. Then do all of the stuff. But now the problem is, how do we pop it before the return statement? I guess we've got to do that in return. Like here. So, let's have a look. Pop. Welcome back in, DirectExe. DirectExe says, hello again, I realized the whole AI thing has just started taking off as of 2023. Yeah, that was a few years ago. And I should focus on getting good at languages like C++ if I want to be a pro game dev. I need to find my own path and worry about starting an AI agency later. Or I could do both, but dedicate less time to the AI agency. Yeah, I mean, it depends what goals you want to set for yourself, right? Okay, you were right about that pushing and popping. That does seem to be a better solution here. Or at least it's less confusing. Okay, so that's good. Ian says, you should learn manual programming regardless. AI is a tool/accelerator, can't accelerate when you aren't moving. I like that. That's a good way of putting it. Like a multiplier. 0 times 0 is 0. DirectExe says, I need to do like you're doing, tuning out the noise and not worrying about being behind other CS graduates or vibe coders. Yeah, I mean, I don't know how old you are, but not caring what other people do is good. Like, why does it matter what other people are doing? You've got one life. So just do what you want to do. Who cares about what other people are up to? It just eats you up that they make millions vibe coding. I can't take it. Yeah, as I was saying before, they're focused on something different. They're not focused on engineering. They're focused on product delivery, product creation, service creation. It's a totally different skill set. They just use programming to build software products or vibe coding, whatever, which is fine. If that's what you want to do, then do that. You could always make millions and then do programming. All right, so this is now working. That's good. 124. All right, I've got a little bit of time. What happens when we run this? Oh, it just works. What? Okay, let's make something more complex. Z 40 plus 73. I should have done numbers that I can add in my head. What is that? 113. 113. So 2 plus x minus z. That is most certainly incorrect. DirectAC says, I used to like the idea of a dream job, but I'm realizing true freedom is not having to answer to a corporate overlord. The only way to level up my skills in coding and get experience is through entering the corporate rat race, aka the Matrix in America. Well, yeah, I don't know about that. Why is that the only way to level up your skills? You can just program, if that's what you want to do. Just program the computer, and then you get better. Ian says, I don't think multiple returns is going to generate properly because of the multiple returns. Last time I tried to do that, the assembler got mad at me. Yeah, it's probably not going to work right now. DirectDXC says, I'm nearly done with college and I'm realizing I want to be more than a game dev. Okay. I'm not sure what you want me to say. Just do more than. That makes sense, right? Ian says, I mean, I guess, unless you're rich, you can't just program whatever you want all day. So in a way, you're right. Like DirectDXC, I guess. Yeah, I mean, you can't just program all day on whatever you want. Most people can't, but you still have like another 8, let's say 5 to 8 hours after your day job. Or you could get a day job that's not that demanding, like, you know, what are they called? Concierge or something. I know a guy who was a concierge and his job was sitting in an empty building all day doing nothing. So, you know, you can get a job like that and just do programming. Yeah. This is totally busted. We'll make it a nice easy number, 30. So this is returning 30 as if the last argument here is somehow, yeah. Data entry, huh? Yeah, I don't even know what a data entry job is. I mean, I can imagine, but I've never actually seen one in real life. You could get a data entry job. I assume it's literally copying data from one format to another or from scans or something. I don't know. But, you know, if it's digital, you could get a data entry job, figure out a way to automate it so it's really efficient, but then don't tell your boss that you've done that. Right? Ian says, what does the expression AST look like? So Y looks like We're subtracting 2 plus x from z. 2 plus x is, what is that? 2 plus x, that's 3 from z, which is 30. So it should be negative 27, I guess. What if I change this to a plus? I don't even know if I'm handling minus properly. 33. Okay, I think I'm just not handling the minus case. Yeah, like you can see here. Plus, slash. I just don't, I don't handle sub. So what if I do handle sub? So that would be minus and then sub 27. 27? Hang on. 2 plus 1 minus, no, that's wrong. Oh, it's unsigned. No, unsigned doesn't matter. There's no signedness. This is backwards order of operations. But I am sure that I had this working in the parser. Let's see. Shouldn't even have negatives. Okay, maybe I shouldn't use these numbers. So I'll use like a 10, 20, and a 1 and a 2 up here. So this is going to be a, resolved to a 3. This is going to be 30 minus 3. So we should get 27 in this case. And we got negative 27. What? Alright. Something is funky. Aren't the signed functions separate? Yeah, there's like imul. Oh, actually, I don't know. I need to look at the x64 ISA. But yeah, all right. Let's just see if we can quickly make subtraction work. Okay. So I'm just going to say y is 10 minus 2. Return y. We get negative 8. So this is obviously wrong. Is that because... What do we actually output here? Where's the sub? So we're moving into RCX, the value that's stored at offset 16, which is 2. Yeah, so that's the wrong way around. 10 minus 2. It's storing them the wrong way around. I really don't think I should just swap this, because that might work, but I don't think that's the right answer. It could just be that these need to be swapped. Source and destination. Is the source the one on the left, or is it the one on the right? Because we're going down the right side. Ian says, looked it up, and sub and add work for both signed and unsigned. Okay, thanks. Now we get 8, which is correct. Yeah. So, but what about if we add? Well, add is always going to work, because it doesn't matter which order they're in. 10 plus 2 minus 3, so expect to get 9. We got 9. Plus 2, we should get 11. I'll just add a large number here. 21. Okay, that's working. Yeah, I think these are in the wrong order, which I'm surprised didn't break a whole lot of other things. Let's see if divide works. 10 divided by 2. No, does not work anymore. Divide was pretty involved. And I swapped the operands here. So that could be why. Hang on. This just says div. Oh, now I don't know. I don't know. I'm gonna put a fix me here. Check source dest order. Yeah, it's totally broken. Well, I think we scared away DirectExe. Sorry about that, brother. Hope you figure it out. Cool. Yeah, so I'm gonna have to fix divide, but now at least subtraction is working. That's good. Let's see. Well, I do have a little bit of time, so let's just see if we can fix divide right now. So I'm going to check the source destination order. What does this say? 10 divided by 2. Well, that makes sense. So 10. DirectExe is still here. Just setting up. I'm just setting up Unity Engine on my gaming desktop. Oh, cool. Nice. Yeah, I actually have a separate computer for the games versus work. Because when I was younger, I used video games as an escape from my crappy life and got super addicted. And still can be a problem if I'm not careful. Okay, so I was using all this old notation without the make binary thing here, but essentially store low 64 bits of dividend in RAX. But in this case, the dividend is the... Which one is it? Let's see. Oh, my stomach is very rumbly. Very rumbly. I'm super hungry. I feel like this is not the right thing. 21. Yeah, well, that's obviously wrong. Invalid combination of opcode and operands. Okay, let's have a look at that. 19. Oh, we're just pushing nothing. Did I make push here? Push, push, push. Pop, pop, pop. Yes. So pushed RAX, RCX, RDX. What? Okay, I'm going to change this. I think this is just weird. Make unary push. I remember why we have to do this, because divide uses specific registers, so we've got to save them all and then pop them back. Alright, so that's that part. And I'll just copy these and put them in reverse order at the bottom here. Crap, which order? Like that. RDX, RCX, RAX, there we go. Alright. So it didn't produce malformed code, but it also didn't work. DirectXC says, I woke up 3 months ago and realized I would start my day gaming purely out of habit. I didn't even feel excited to play video games. I was just doing it because I had no plan for my days. That sounds very familiar. Very, very familiar. Yeah. I would play this game called Oxygen Not Included. I think I played like 3,000 hours of it. Which really is not that... I mean, it's a lot, but it's not that much. Compared to... I probably played way more hours of Dota, Counter-Strike, or whatever MMO I was playing. And yeah, sometimes I would just leave Oxygen Not Included running in normal speed while I slept. And so I guess that doesn't really count as time. But then I would just check it in the morning, make adjustments to my colony, whatever. Really fun game. Ian says, my current addiction is reading online comics. Managed to get out of playing games by getting bored of them or making it so I have to play with more people. And most people are too busy to play together, so that solves itself. Yeah, now that I'm older... Actually, that's not true. All of my old friends that I used to play games with from Sydney, they still play Dota and Deadlock like almost every day. But I don't play those games, so I guess it doesn't really matter. So alright. Gotta load the divisor. Obviously that doesn't work. How does this make sense? Oh, clearing the high bit. Okay, that's fine. ThreatDXC says, I got hooked on Battlefield 6. Nowadays, you could lock me in my room with my PS5 and I get bored after a while. I still enjoy gaming, but I only do it if people are on Discord. It's kind of good when you get to a stage like that. Because now you've got sort of a... not exactly a safety net, but you've got like a requirement. If no one's on Discord, then you can just tell yourself, yeah, I don't want to play by myself. Gives you an out. Whereas if you're playing games by yourself all the time, at one stage I had to lock my gaming computer up. Well, I didn't lock it up, but I unplugged it all and I put it in a cupboard in another room. iPlaysDev, hello, welcome back. How you doing? So this, it's optimizing it. Yeah, so annoying. I need to look at how divide works. X64, is it iDiv? How did I figure it out last time? Sign extend. Is that what I did here? Okay. Pretty sure if I just swap these, it'll be what I should have had. No, that's wrong. I'm gonna need to look at this with a more critical eye. Ian says, thankfully I'm horrible at multiplayer PvP, so I never got into that. Yeah, those games are really addictive, and you can play them over and over and over and over and over, because every time it's different players, different people choose different characters. If it's a game with multiple maps, then it could be a different map. Yeah. All right. How? What? Okay. Let's just look at this again. So we store low bits of the dividend. Which one's the dividend? This one? This one? 10, right? Oh my god. I'd have to look this up. Which one is dividend? It's the bottom one. Wait, the quotient is the top? I thought the... Oh, no. Alright, my alarm just went off. I got a call in 15 minutes. So let's see if we can fix this. 12 divided by 3. 12 is the dividend. Yes, I was right. 3 is the divisor. The number you divide by. Okay, good. I just want to make sure. Ian, you can't say dividend equals divisor. What? That's confusing. Alright, so. Dividend divisor. What do you mean that's what you learned? You learned that the same thing. Well, then what's this number at the bottom? Dividend equals divisor, number you divide by. Then what's the 10 called? Quotient is the one being divided. See, this says the quotient is the result, and then the remainder is if there's some kind of remainder from the... And right here it says the same thing. The quotient is the answer. But then if it's written like a fraction, the top number is the numerator, which is also the dividend, and the bottom number, the denominator, is the divisor. It's been a while since primary school, to be fair. That's true. It has been a while since primary school. Yeah, well, I just had to look it up, so don't worry about it. Cool. So we're going to store the dividend in REX. So the dividend is 10. So in this case, is that the source or the destination? I'm just going to do a print. Where is it? Yeah. So the source is offset 16, which is... What do we move into offset 16? Number 2. So this is the divisor. So that has to be DST. I'm going to rename these, actually. Then I can just use the names. Okay, move the dividend into RAX, clear 64 bits in RDX, clear high bits, load divisor into where? It says load into DST. Load into RCX, obviously. Then do the division. Destination is... I guess destination is going to be the destination, which is going to be the divisor. So that's where we're going to store it. Then the result is in RAX. Hang on a second. So the result after we do this, let's have a look. Ian says, I might be confusing names, but my mother tongue is not English. Okay, fair enough. DirectXE, I see so many guys flying through interviews, speaking confidently. I should start doing coding live streams and content creation just so I can enhance my public speaking skills. Ian says that's a good idea, only if you can handle it. Public exposure can be quite a lot, even to a small audience. Well, I can tell you that the first couple of times that I streamed, I was sweating the entire time. I was really nervous. Now I don't really care so much. I mean, I care a little bit, but not really. All right, we're gonna have to fix this on the next stream. My brain is not working. So I'm gonna go back to the README. Where is it? Oh no, it's to do. Okay. We did create a data structure to store scoped symbols. We didn't get float parameters working. Do we need to manually sub? Okay, that's still a question. Stack allocate all locals, that's done. Okay, fix, divide. We'll put that for the next stream. Very good. Okay. Yeah. I think that'll be one goal for the next stream. We also need to test nested scopes and with early returns. Actually, test nested scopes and test early returns, test scoped, test returns in blocks. All right, so this is our goal for the next stream, which, I don't know, I might do another nighttime stream. I do have time to do one tonight, but last night I was really tired and it was kind of hard. We'll see. But yeah, I want to thank you guys for tuning in once again. I appreciate the help. And good luck with your day and your week. And if you're around, I'll see you in the next one.